We're looking at a midterm exam, Unit 2, Chapter 4, Rational Expressions. We're going to look at some multiple choice questions and some constructed response questions from Chapter 4 on the midterm exam. You may wish to pause the clip before attempting each question and attempt a question on your own and then watch the solution. What are the non-permissible values for the rational expression? So remember, non-permissible values is what values for the variable would make the denominator 0. And so we're looking at these two factors, 2 subtract x. So here 2 subtract x cannot be 0. So 2 cannot be x. Or x cannot equal 2. We have 4x plus 1 cannot equal 0. So 4x cannot equal negative 1. X cannot equal negative 1/4. So we see that that would give us answer A. So make sure we identify the non-permissible values as the values that would make the denominator of an expression 0. Which expression is equivalent to x plus 10 over x plus 4, where the non-permissible value is negative 4. We have to remember, we have to simplify an expression to get x plus 10 over x plus 4, and the non-permissible values must be the same. If two expressions are equivalent, they will have same NPVs. So if we have a look at the first one, it's not even simplified to be equivalent to this one. All they did was take half of 10 and half of 4. And here the NPV is x cannot equal negative 2. This one's out. If we look at this one, we have to factor the numerator. We have a common factor of x plus 10 over x outside x plus 4. When we cancel the common factor of x, we do have x plus 10 over x plus 4. We shouldn't choose this example, or this, we shouldn't choose B as our answer right away, as we have to check for NPVs. The NPVs of this one would be x could not equal negative 4, but there's another NPV of x cannot equal 0. So this is not, although it's close, it's not the correct answer since the NPVs are not the same. In the next option we have just 3 is multiplied by the x. This will give us, we cannot simplify this to give us the x plus 10 over the x plus 4. And the NPVs are not the same. So once again, C is out. When we factor D, we have 5 outside of x plus 10 over 5 outside of x plus 4. Cancel the common factor of 5, and we do have x plus 10 over x plus 4. So we're halfway there. We have to decide the NPVs to make sure they are the same, and here x cannot equal negative 4. So it must be D. So you have to be very careful. It must simplify to be an equivalent expression, but in order to be equivalent, it must have the same NPVs. Which rational expression has non-permissible values of 0 and 5? So in the first one, this will give us x cannot equal 5 and x cannot equal 0. So that one's good. Here we only have x cannot equal 5. The numerator, we're not concerned with the numerator in this point. We are concerned with a numerator if we're dividing rational expressions. We're concerned with the denominator in the second rational expression, but in this case, it's not included. Here we have NPV is going to be x cannot equal 0. And here there are no NPVs. There are none. And so we have our answer being A. We have to simplify rational expressions. So the first thing we should do when we're simplifying rational expressions is factor the numerator and denominator if possible. So we have a common factor of 3 And we have a difference of perfect squares in the denominator. And so we have to cancel out the common factor of x plus 4, and that will leave us 3 over x subtract 4, where the NPVs will be x cannot equal 4 or negative 4. Now we see that all the NPVs in our options are the same. So our answer would be B. Once again, we have to simplify. A big error here is that some may want to cancel the term x squared and x squared and be left with 1 over negative 3x. This is incorrect. You're canceling terms, not factors. So we will factor first. We have x squared over x outside of x subtract 3. Now there is a common factor. There is a common factor of x, leaving x on top, or in the numerator rather. We have x over x subtract 3. This gives us D. So be very careful here. Do not make this error of canceling terms and not factors. We have simplify. We're going to multiply two rational expressions. So we shall factor first. So we have x plus 5 over x plus 6 times x plus 6 over, and this is the difference of two squares. So we have x plus 5, x subtract 5. And we cancel common factors. In the numerator and denominator, and we're going to be left with 1 over x subtract 5. All the NPVs are the same, so that won't affect which answer we choose, and we have C. So we're going to simplify two rational expressions by dividing. So we have 6x over 20. We have to multiply by the reciprocal. When we're dividing rational expressions, we multiply by the reciprocal. Now that adds an NPV here. We have to check for NPVs in the numerator and denominator. Now all the NPVs, of course, our answers are the same. So let's just cancel some common factors. We have a common factor of x, leaving x squared in the denominator. We have a common factor of 5, leaving 4. We have a common factor of 2. This would give us 3 over 4x squared. Answer will be D. Here we're going to simplify by adding two rational expressions. And when we're adding and subtracting rational expressions, we have to have a common denominator. In this question, the denominators are like, so we just have to add the numerators. We have x subtract 2 plus 3x plus 4 all over x plus 1. This will give us 11x plus 2 over x plus 1. Now if we could factor the numerator, then we would, and we may then be able to cancel a common factor of x plus 1, but this is not the case here. We see the answer is D. Here we're going to subtract two rational expressions. And once again, in subtracting, you must have a common denominator. So it's easier to find the common denominator if you factor the expression. And so we can see that the lowest common denominator would be 2x plus 4. Since we can multiply x plus 4 by 2 to get the 2x plus 4. That will give us negative 14x over 2 inside of x plus 4. Subtract 3x over 2 inside of x plus 4. Negative 17x over 2 inside of x plus 4. There are no other common factors to cross out. So we have D. A student simplifies 3 over x subtract 4, subtract 2 over x, where x cannot equal 0 and 4. Which step does she make the error? A good strategy to determine the error would be to complete the problem on your own. And so we have, we find the lowest common denominator to be x outside of x subtract 4. So we would multiply the first expression by x over x, and multiply the second expression by x subtract 4 over x subtract 4. You see, that's what they did in step 1. So that one's okay. When we get that, we get 3x subtract, and 2 times x subtract 4 will be 2x subtract 8. You have to remember we're subtracting the full expression over x outside of x subtract 4. So this step is okay. When we're subtracting, we have 3x subtract 2x, and we're subtracting a negative 8, that's plus 8, which here is where they went wrong. So it would be step 3. This gives us x plus 8 over x outside of x subtract 4. Algebraically solve for x. This is a constructive response question, the non-permissible value being 0. So in order to solve, when we're solving, we have to multiply each term by the LCD in order to eliminate the fractions. And the LCD here will be 8x. Since I can multiply 4x by 2 to get 8x, and I can multiply 8 by x to get 8x. So I will multiply each one of these by 8x. So I have 8x times 3 over 4x plus 8x times 7 over 8 equals 8x times 5. And so we can see there's a common factor of x and a common factor of 4. That leaves us with 2 here. So 2 times 3 will be 6, plus we have a common factor of 8 here. So we have x times 7, which would give us 7x, and that equals 40x. So we would have 6 equals 33x. 6 over 33 would equal x. This gives us 2 over 11. Here we have to simplify and state the non-permissible values. And so let's factor each expression first. So we have 10 outside of x plus 4 over 2 outside of 5 plus x divided by 3 outside of x plus 4 over x plus 5, x subtract 5. Now, so far in the denominator, this will be an MPV, and this will be included in the MPVs. Yet, we are going to multiply by the reciprocal, so we still have 10 x plus 4 over 2, 5 plus x, but we're going to multiply by the reciprocal. So we have x plus 5, x subtract 5, over 3 outside of x plus 4. Now we have a new denominator here, so this will also be included. This gives us 3 expressions to be included in the MPVs. This was once in a denominator, now this is in the denominator, and this will be in the denominator. So the values that would make any of those expressions 0 are part of our MPVs. Let's cancel any common factors in the numerator and denominator now. We have x plus 5 and x plus 5, x plus 4 and x plus 4. We have a common factor of 2 here. This would leave us 5 times x subtract 5 over 3. And our MPVs would be here x cannot equal negative 5. Here, x cannot equal 5. We have x cannot equal negative 5 again. And right here, we have x cannot equal negative 4. So our MPVs would be x cannot equal plus or minus 5 and negative 4. So this will be a popular constructive response question from this unit. If Karen takes, it takes Karen and Jessica 6 minutes to collect their school's recyclables when they work together. If Karen works by herself, it will take her 5 minutes less than Jessica. If Jessica collects the recyclables by herself. Set up a rational equation to model the situation. So we have Karen, we have Jessica, and then they can do it together. So, together it takes them 6 minutes. If Karen works by herself, she's 5 minutes less than Jessica. So if Jessica is x, Karen is x subtract 5. The fraction of time that they would take when they do it would be 1 over x subtract 5, 1 over x, and 1/6. So the rational equation would be 1 over x subtract 5 plus 1 over x would equal 1/6. We have to use the equation to algebraically determine how long it would take Karen to collect the recyclables if she works alone. So since this is a rational equation, we have to determine the lowest common denominator. So we can multiply each term by the lowest common denominator to eliminate the fractions. So the lowest common denominator in this case would be 6x outside of x subtract 5. So we have 6x x subtract 5 times 1 over x subtract 5 plus 6x x subtract 5 times 1 over x, which will equal 6x x subtract 5. That's the lowest common denominator, multiplied by each term. Now we have some common factors that we can cancel to eliminate the fractions. So I'll be multiplied by the lowest common denominator. So you have x subtract 5, x subtract 5. That means we're going to multiply 6x by 1. We have an x and an x. So that means we're going to multiply 6 times x subtract 5 by 1. We have a common factor of 6. So we're going to multiply x inside of x subtract 5 by 1. So when we simplify, we will get 6x plus 6x subtract 30 equals x squared subtract 5x. So you see we have a quadratic. That means we're going to have 2 possible values for x. Let's rearrange and solve for x. So that would give us 0 will equal x squared subtract 17x plus 30. So to solve a quadratic, we could use the quadratic formula, or if the expression is, or if the equation is factorable, we could factor it. This equation is factorable, so we have 0 equals x subtract 15 times x subtract 2. So x would be equal to 15, and x would be equal to 2. Now if x equaled 2, that would give us 2 subtract 5, and Karen would take negative 3 minutes. So this one is not a valid answer, so we will reject it. The answer is Jess will take 15 minutes. Another way to set up this problem is your rational equation could be what they do together divided by Karen plus what they do together divided by Jess will equal the full job. In this case, the LCD would be x outside of x subtract 5. And we still do the same by multiplying each term by x subtract 5. X outside of x subtract 5. So we would have times 6 over x subtract 5 plus x outside of x subtract 5 this will equal x outside of x subtract 5 times 1. When we cancel out the common factors to get them to eliminate the fractions, we'll get 6x plus 6 outside of x subtract 5 equals x outside of x subtract 5. So we'll still get the same equation. We'll have 6x plus 6x subtract 30 equals x squared subtract 5x. Once again, a quadratic, which we can use the quadratic formula to solve, or factoring if possible. 0 will equal x squared subtract 17x plus 30. And this again will give us x subtract 15, x subtract 2. So that gives us x equals 15, x equals 2, which we would have to reject this one, since if it takes Jess 2 minutes and Karen will be 5 minutes less, a value of 2 would be -3 for Karen. So we must reject this one. This question is a popular question from this unit, and would more than likely show up on the constructor response question of the public exam.